Okay, in this video we're going to have a look at how to write the equations that happen at the electrodes during electrolysis. So what I've got here is, here's my electrolysis system. I've got a DC power supply, I've got two electrodes, I've got a cathode and an anode. And then what I've done is just put some examples of different cations at the cathode and different anions at the anode. Okay, let's have a look at how we work out an equation that's taking place. So what we need to remember here is the cations at the cathode, they are going to pick up electrons, because what we're going to try and do is get rid of this positive charge on them. The way we do it is by picking up negative electrons. So a sodium ion, Na+, needs to pick up one electron, and that will form sodium. An Mg2+, so 2+ ion, will need to pick up two electrons in order for that reaction to happen at the cathode. Aluminium 3+ would need to pick up 3 electrons to form aluminium. I've included hydrogen. You notice these are all metals, but hydrogen is not. The reason I've put this in there is because if our electrolyte, the solution that these electrodes are sat in, contains water, then we will have hydrogen ions floating about in there. This hydrogen ion, single plus, needs to pick up an electron to make hydrogen, but we must remember that hydrogen is diatomic, so that should be H2. Therefore I need 2 electrons, and I have to have 2 ions at the start to make that work. Okay, this side at the anode, here's my anions. So what I've got here is a chloride ion. Now what we're going to do is get rid of these negative electrons that are here. So this has got 1 negative electron. We're going to take that to have no electrons, and it's going to release the electron. Remember that chlorine is diatomic, so I need 2 of those. Therefore I need 2 chloride ions, and that will release 2 electrons. An oxide ion, 2-. So this needs to lose 2 electrons. We're going to be careful here because I know that oxygen is O2. Therefore I need 2 of these. And because I need 2 of these, it'll actually be 4 electrons in total, 2 for each one, to make that work. Hydroxide ions, this is the tough one, the tricky one. Watch some of the early videos that show you how to construct this, but you should remember that this forms 2 lots of water, 1 lot of oxygen, and it releases 4 electrons because I need 4 lots of those hydroxide ions to make this work. Again, I've included this one because along with H+, these two form from water, and if we're doing aqueous solutions in electrolysis, then we will need to consider these 2 reactions. Just, it's worth noting here that anything that's a positive ion will pick up 1, anything that's 2+ ion will pick up 2, 3+ ion is 3. Same here, -1 needs to lose 1 electron for each ion, and -2 is 2 electrons for each ion. So just, you can use the patterns in here to help you do any question you want to do. Something to bear in mind though is this idea of OILVIG. This stands for oxidation is loss, reduction is gain. So what does this mean? If we look at our equations on our sheet, this side here we've got sodium gaining electrons, magnesium gaining, aluminium and hydrogen gaining electrons. So these equations here are all representing reduction is gaining electrons. So these are all reduction reactions, and these reduction reactions are happening at the cathode. On this side, these all start off with electrons. They lose their electrons to form the molecules that we can see here. So because this is loss, this is oxidation, and oxidation is happening at the anode. So some key points in there for you to pay attention to. Make sure you can work out the equations. Make sure you know the cathode and the anode, and its reduction at the cathode and oxidation at the anode.